Welcome back, mathematicians. Today we're going to talk about thirds. If the whole is divided into 3 equal parts, each part is called a third. You can create thirds by partitioning a whole into 3 equal parts. So let's take a look at our shapes. First, we have a circle. This circle is partitioned into 3 equal parts. 1 part, 2 parts, 3 parts. 3 equal parts. Let's look at this rectangle. This rectangle is partitioned with 2 horizontal lines to create 3 equal parts. 1 part, 2 parts, 3 parts. This rectangle is partitioned with 2 vertical lines to create 3 equal parts as well. This rectangle is partitioned with horizontal lines to create 3 equal parts. Now these all represent a third. If we were to shade one part of this rectangle, we would say 1 part is shaded. We would write it as 1/3 of this rectangle is shaded, or 1/3. 1/3 of the rectangle is shaded. If we were to look at this circle, again, we have 3 equal parts. If I were to shade this part and this part, now how many do we have shaded? 2. We have 2 equal parts shaded. So we would write that as 2/3. We would write it with words like this. 2/3. Now, if I were to shade the whole shape, let's shade this whole rectangle. 1 part, 2 parts, 3 parts. I now have 3 parts of my rectangle shaded. I would write that as 3 is my numerator because 3 parts are shaded, and 3 is my denominator because I have 3 parts in total in my shape. 3/3, but my whole shape is shaded. So 3/3 equals 1 whole, because 3/3 equals 1 whole shape. Again, if we look at this rectangle and we shade 1 part, 2 part, 3 parts, we would again write this as 3/3 or 1 whole. Let's take a look at these shapes. Let's look at this circle. This circle is partitioned into 3 parts, but are these parts equal? Here's our first part. Here's our second part. And here's our third part. You can see that these parts are not equal. So this would not represent a third. Let's look at this rectangle. This rectangle is also partitioned into 3 parts using diagonal lines. But we can see that this creates a triangle. This is a triangle. And then this is another shape. Are these 3 shapes equal? No, these are not equal parts. So this does not represent a third. Let's take a look at this shape. This shape is partitioned into 3 parts. But again, these parts are not equal. So we cannot represent this as a third. Finally, we have another circle. This circle is partitioned into 3 parts. But these parts are not equal. We have one part here. We have another part here. And another part here. These parts are not equal, so we cannot say that this is a model to represent a third.